Welcome to the R Workshop, hosted by the Water Q2 Understanding Water Quality and Quantity in the Limpopo Basin project. This project is funded by the U.S. Agency for International Development, Regional Development Mission in Southern Africa. This work is supported by the United States Agency for International Development, Southern Africa Regional Mission Fixed Amount Award. This work reflects the work of the authors and does not necessarily reflect the views of USAID or the United States government. Before we get to the workshop, a quick note about our project overall. It includes data monitoring and sharing, research on remote sensing of water resources, training and stakeholder engagement, and enhanced networking for scientists working in the Limpopo Basin. You can find out more about the Water Q2 project and the partner organizations, Duquesne University, University of Venda, and Rensselaer Polytechnic Institute on our website.
Hi everyone, my name is Rachel Pilla and I will be your instructor for the R workshop upcoming next week. I'm going to take the next few minutes and just give you an introduction into what to expect from the workshop and some things that R can do that we'll learn in the workshop and beyond, just to get you familiar with some of the things that we'll be doing in the next few weeks and how you can go beyond and extend what we've learned in this introductory workshop. So R is a free and open source program that allows you to do a huge range of statistical and computational tasks. That means there's no paywall, and that also means that anyone who uses R can share the information, share their code, and improve the program altogether without any fees, which is always great for international collaborations and students and faculty and government employees across the world. Because it's open source, you can do simple Google searches, for example, that can give you really effective solutions to the questions or troubleshooting issues that you're having in R. And that's something that we're going to walk through on day 1 or 2, how to do these searches, so you kind of have an idea of how to solve some of the issues that you come across once you start working more on your own. It's very widely used in the sciences and in a lot of other STEM, mathematical, technological sorts of fields. It's rapidly growing in popularity. So, this sort of sharing of code and open source programming makes it really, really useful for these large collaborations. It's really great because it can handle really advanced computation, statistical analyses, really large data files, mathematical models, far more than Microsoft Excel, for example, could handle. Um, and so using R, you can do pretty much every step of your data processing, your analysis, your computations, your graphs and visualizations, and even some science communication efforts, all within R, which is really, really exceptional. And it's really nice because there's lots of different styles of coding that you can use and effectively get the same output or results. When you open RStudio, hopefully you have that downloaded or will download it before Monday. You'll see 4 panels, and I'll kind of walk you through what these are. And on Monday, we'll get to using these really in depth. So in the upper left-hand pane is your R script, and this is where you're going to write and edit your code. That's sort of the soul of R, where all of the action happens. RStudio is really awesome because it has these cool color coding functions and sort of autofill functions that can make your script writing really easy, that can help you reduce the amount of errors you end up writing. Below that is the R console, and that's where all of the commands actually run and where all of your results, such as your statistical analyses and output, will appear. We'll talk a little bit about what to look for there more on Monday. And in the upper right-hand pane, that is your environment. This keeps tracks of every piece of information that you create and save in R, and a little bit of information about how large it is, what type of data is in it. So it's a really good way to sort of keep track of everything you've done in R and know what everything's supposed to look like. And then in the bottom left-hand page, there is sort of this mix of tabs here, from plots, packages, help, for example. When we start to create plots later this week, that's where all of your plots are going to initially appear. You can also look to check on packages there, which we'll talk about a little bit more on Monday. And very, very importantly, this is where you can find important help files that would tell you a lot about different functions and different statistics and different calculations and how to use them effectively in R. A lot of these also have examples that you can copy and paste in the console, for example, to get yourself familiar with how to use these specific functions. We'll talk more about this on Monday and then start working with all of these different sections of RStudio then as well. But what can you do in R? And like I said, you can do almost everything in R. From cleaning, transforming, managing, and summarizing your data, getting it into different formats, or doing some summary statistics or some descriptive statistics, doing some sort of viewing of your data in different ways. R can take care of all of that. We have almost an entire day dedicated to all of the different ways that you can work with your data to get it in clean, tidy formats. You can create beautiful graphics and plots. This is one of my favorite things to do in R. And again, we're going to be spending some time learning how to make plots like this. This might be data you're familiar with, for example, because we're going to end up making this plot before the end of the week. It shows the daily air and water temperature trends at the Mutale Weir over about a little over a year of data. So these are really high frequency daily data, and you can see the seasonal trends and see how both the air temperature and water temperature patterns pair together. Um, we have a lot of different ways of plotting and visualizing data. So we'll spend a lot of time about the theory behind that, but also how to do this and how to make different types of plots based on different types of data you have and how you can best present those to scientific reports or publications, for example. You can conduct a huge range of simple to very advanced statistical analyses. Things like descriptive statistical summaries, hypothesis testing, frequentist analysis, trends over time, trends between variables, and more advanced things that are kind of beyond the scope of this workshop, but things like Bayesian analyses, cluster analyses, all that type of stuff. R can handle all of it. So if you have an interest in any type of advanced statistical analysis, even if we don't talk about it during the workshop, I can about guarantee that there's some Google search help or some different packages that already exist that can help you on your way with that once you know the basics in R. You can do a lot of cool spatial work in R, such as creating maps. Again, these are data and maps that we're going to be creating this week. And you can do a lot of geospatial analysis as well. You can do a huge range of both building and running mathematical models, such as these SIR models that are related to epidemiology. I do a lot of work with lakes, for example, and I run a lot of lake ecosystem models in R as well. I've been fortunate enough even to work to build a package in R with this. There's some cool functions and packages in R that help you communicate your data and communicate your science really effectively. R Markdown is one of these, and this can generate really nice reports directly from your code so you don't have to rewrite everything that you've already done. It can incorporate plots and a whole bunch of analyses really, really nicely. So you can make really cool reports and communications from your R code. I mentioned before you can build packages and share all these packages. There's over 17,000 packages available in R. And these are just little boxes of new tools that other users have created and shared that then become available to you. So you don't have to reinvent the wheel of writing new functions or writing new pieces of code. You can just use these packages if they do what you're expecting them to do. And then finally, one really cool thing that R does that we're not going to really talk about during this week is create interactive, shiny apps. And so this is an example of one that an intern this past summer worked with me to create to look at lake data. These are another really great way to help communicate your science in a really user-friendly and interactive way. And so I'm going to actually demonstrate how this particular one works for you so you can get a feel for what the potential possibilities in R might look like. And I have a link copied in that PowerPoint. So if you want to check this out on your own time, it's openly available. So this looks at some long-term changes in some lakes that I study in Pennsylvania and the United States. It has information about the lakes, and we have multiple tabs up here. So you can look at information about the different types of variables we measure. And then it has a couple of tabs that have different plots that the user can generate. So here we can look at trends over time of different lake and different variables. So using this R Shiny app, you can make this really nice interactive interface where you click on a specific lake and then this plot is going to update. You can click on different variables, for example. Let's look at chlorophyll, for example, here. And the plot is going to update again automatically. And then you can choose if you want the surface, middle, or bottom of the lake. And all of these things are going to update automatically based on this code that we wrote entirely in R. It also gives you information in a data table format, again, that you can even download here. And we have other tabs that have similar types of data that you can utilize um, using this long-term Shiny app. It's really great for communication. And once again, you kind of learn a lot of the basics in R. You can start building these for yourself to help communicate your science to the public, for example. And so that's again just a taste of some of the things you can do in R. We'll cover about half of these things during the workshop, and after that, hopefully you can expand on your skills and really figure out what you want to do and how R can help you to do it. Because there's so much you can do in R, and I am so excited to be sharing all of my background in R with you to get more people working in R to help you move forward in your science and your research and whatever career path you have. So I'm very much looking forward to seeing all of you on Monday morning. And don't forget to make sure that you follow the instruction and downloading guide to make sure that you have everything installed on Monday so we can get off to a nice quick start and get working in R.